Hi. Now, how to integrate, store, and analyze unstructured data? There are several approaches. Some of them are loose coupling and tight coupling.
The loose coupling approach, called virtual mediated schema, provides an interface that takes the query input from the user, transforms the query in a way source database can understand, and then sends the query directly to the source databases to obtain the result. In this approach, data does not really remain in the schema and only remain in the actual source databases.
However, mediated schema contains several adapters or wrappers that can connect back to the source systems to bring data to the front end. Now we will identify the main approaches to the integration of heterogeneous data sources.
In case of tight coupling approach, which is often implemented through data warehousing, data spool over from disparate sources into a single physical location through the ETL process. The single physical location provides a uniform interface for querying the data. ETL layer helps to map the data from the sources to provide a semantically uniform data warehouse. This approach is called tight coupling, since this approach data are tightly coupled with the physical repository at the time of query.
In case of data warehouse, unstructured data is transformed to structured data. In case of Hadoop distributed file system, every type of data can be stored with no transformation.
Now we will see how to integrate unstructured data. The other way of implementing the tight coupling approach is through a distributed file system, also called DFS. DFS is not a new technology. However, its use on integrating and storing heterogeneous data is novel. All disparate data sources are selected, transformed, and loaded to the HDFS. The data preparation process can be before or after loading data to the HDFS.
Now we will see how to store unstructured data. As I have said before, data lakes have been a very used solution for storing heterogeneous data sources. However, it's not the only one. There are some database managers that can store any type of data source.
In the case of Hadoop, it started with an effort to build a web-scale search engine. Doug Cutting and Mike Caffarella set out to develop a distributed storage layer that satisfied the following requirements: schema-less with no predefined structure, capable of handling component failure without human intervention, automatically rebalance to even out disk throughout cluster. After it was finished, they named it Not Distributed File System, NDFS, and then Hadoop Distributed File System, HDFS. Now it's time to know how to analyze unstructured data. According to your business strategy, you need to identify what kind of analysis you need to do, which might be descriptive analysis, predictive analysis, or prescriptive analysis.
Other point to consider is if you have business experts that can provide some knowledge to your data. If this is the case, then you can do supervised analysis.
The third main issue is what analysis tools would be more productive to use. If you have technical experts, they can analyze without user interface. If they are not very experienced, they can start using a data mining graphic user interface tool. There are some conditions on analytics that we need to be aware of. The complexity of unstructured data lies within the language that created it. Human language is quite different from the language used by machines, which prefer structured information. Therefore, the goal of an unstructured data analytics tool is to build a bridge between these two very different languages. Using semantic analysis and natural language processing, there are some tools that guide you through data discovery to help you with predictive analysis.
Ask your questions using your own words and see how this tool supports you in defining your targets and topics, extracting the relevant data, relationships, and patterns you need in order to make decisions with confidence. For example, what would be the probability that a specific medical treatment helps to deal with brain cancer? Other condition to take into account is the response time for analysis and making decisions. The decision is taken in real time or not.
Well, in order to analyze data on real time, there are some options such as the use of in-memory databases such as SAP HANA and Spark. The SAP HANA stands for Smart Data Access Connector, has been engineered and optimized by Intel and SAP to simplify and accelerate data sharing and query execution across both platforms. As a result, analysts can achieve fast query results across petabytes of structured and unstructured data. Many organizations that collect, process, and analyze big data turn to NoSQL databases as well as Hadoop and its companion tools.
Well, we have understood that there are several conditions for analyzing data, such as where they are coming from, their amount, their structure, type of analysis, and response time. As we have seen, there are different options according to these previous conditions. Next session, we will learn to manage big data, the Hadoop framework and its main components: MapReduce process, Plume, Scoop, Peak, Hive, H-Catalog, UCI, and Jar. I'm sure you will enjoy it.